In this video, we're going to walk our user journey and consider the possible failure modes of the infrastructure serving a profile page request. Think back to earlier in this module, where we described how our example infrastructure would serve the profile page request and the rest of the user journey. For the sake of brevity, we're going to discount failures between our users and our front-end infrastructure and assume that the client-side JavaScript we serve from the CDN is only used for secondary activities like ad serving and analytics. This cuts out many large classes of hard-to-measure risks and allows us to focus on failure modes of our serving infrastructure. We can be reasonably sure that we'll capture most of the common classes of failures experienced by the load balancers. Overload in either the load balancers or the web server pools behind them should be observable as elevated latency or 500 errors, and most forms of outright failure have much of the same story. Accidental misconfiguration of request routing or the load balancers themselves will most likely manifest as good known requests being served as 404s, which the prober can catch. Partial corruption of requests or responses due to load balancer hardware failure may well slip through depending on how much response validation our prober can do. This is a risk worth accepting, not only because it is rare, but because the chance of false positives increases as the prober becomes more explicit about its expectations from the response body contents. You don't want your prober to detect every time someone changes on an unimportant detail of the profile page HTML, and the chances of this happening are far more likely than failing RAM corrupting response bodies. We've covered overload or failure of web server tasks at the load balancer, so the largest remaining class of failure is bad code being pushed into production. Given our dual-pronged measurement strategy, this bad code would need to A, be served as an OK response header, and B, serve a response body acceptable to the prober but unacceptable to the user to go undetected by our current SLIs. While this isn't impossible, it's quite a narrow window of opportunity for a bug to sneak through. Making this window of opportunity smaller means making the prober more explicit about its expectations again, and as we noted in the previous module, it can start looking more like an integration test. It's worth discussing our choice to only measure profile page latency rather than including avatar image latency in the SLI. This leaves us vulnerable to slow but successful serving of these avatar images, causing our users to become unhappy. As we said earlier, these images could be relatively large, so they may be slower to serve than the profile page HTML. We are making an explicit trade-off here because slow loading of the avatar image won't block the rest of the page from loading. We assume that we will provide a better overall user experience by having a latency SLI that is not polluted by avatar requests with high and variable latency, which we can set much tighter SLO targets for. The web server has two dependencies it makes requests to when serving the profile page: the user profiles data store and the leaderboards data store. If we assume it's built to serve 500 class errors when either of those requests fails, and will implicitly pass on data store latency back to the client, then overloads or failures in these data stores should be captured by our SLIs too. An interesting possibility here would be to make leaderboard lookups soft fail, assuming the user is more interested in their profile data than the leaderboard, giving them a partial response with the leaderboard missing in the event of a lookup failure. And tracking these failures with a quality SLI might be a better approach than serving an outright failure. If some form of request corruption or bug results in the wrong profile being returned from the data store, unless it affects every user, it probably won't be caught by our prober. This is potentially a big risk, but in our experience, random corruption from hardware failure rarely results in a successful but incorrect response. A software bug is far more likely, but in this case, that kind of thing should be found by your integration tests and QA testing before it ever reaches production. That's quite a lot of stuff to consider, but we hope that you see the value of thinking carefully about failure modes of your infrastructure. We know that our SLIs don't cover absolutely everything, but we can be pretty certain we've covered enough at this point, and we can document the exceptions and justifications and our assumptions along with our SLO targets. We've got some historical request latency and error graphs from our load balancer monitoring, so maybe you could look at that and suggest some targets. We'd also like you to practice walking the user journey and set some aspirational SLO targets for other, more complex user journeys from our previous assessments. Don't forget to choose a measurement window as well.